We're going to go ahead and get started here on our third type of segment. So today we're going to talk about, so far we've talked about perpendicular bisectors, angle bisectors, and today we're going to talk about medians. So a median is a segment that goes from a vertex to the midpoint of the opposite side. So those are the words you're filling in there. It's a segment that goes from a vertex to a midpoint of the opposite side. Do you see the word perpendicular anywhere in that definition? No. So medians do not have to be perpendicular. They just go straight from a vertex, straight across to a midpoint, doesn't have to go at a certain angle. The centroid, which is one of my favorite mathematical words, is the specific name where your three medians intersect. And so just to kind of review last week, what we talked about was, we talked about perpendicular bisectors, and they all met at what was called the circumcenter. You don't have to write this down. We talked about angle bisectors, and they all met in a triangle at a point called the incenter. And now we're talking about medians, which are also going to all three intersect at a point called the centroid. So each name, and you have to start memorizing these because you'll be tested on it, each name kind of corresponds to its own specific type of segment that it's referring to. Okay, now medians kind of have a little bit of a tricky theorem. So last week, those perpendicular bisectors met at this point that was equidistant to each vertex of the triangle. So like from that circumcenter to each corner of the triangle, those segments were all the same. The angle bisectors met at a point that was equidistant to each side, so each little like perpendicular segment was the same length. For medians and centroids, they don't have any equidistant segments. They're going to be split into a little bit of a thirds situation. So again, here are your three medians. Here's one, B to F. So it's starting at a vertex and going to the midpoint of the opposite side. Here's a second one, going from a vertex all the way across to the midpoint of an opposite side, not necessarily at a right angle. And then the third one is going from a vertex all the way to the midpoint of an opposite side. Okay? And they meet at this point called the centroid. When that happens, each median is being split up into like a 2/3 piece and a third piece. So it's not being cut in half, but it's being cut kind of into thirds. So let's just look at this red piece for a minute. First of all, which piece looks longer? BP or PF? BP. Are you pretty sure about yourself there? Yeah, I would agree. BP looks longer. So they're not equal to each other, but BP is going to be 2/3 of the length of the entire red segment, and P to F is going to be 1/3 of the length of the entire red segment. So let's talk about thirds for a moment. Now remember, thirds, when you take a third of something, the operation that you're doing is just dividing by 3. So if this entire segment is 9 units long, and I asked you for a third of that, what's a third of 9? 3. You're just dividing by 3. So each little piece here would be 3. If I said the whole thing was 15, how much would a third be? 5, okay? Now, what if I asked you what 2/3 of something would be? So let me find a number here. Let's say this whole thing is 27 units long, and I said, what's 2/3 of that? What's 2/3 of 27? Okay, very nice. Good quick math, but maybe not all of you were as quick on that. Think about what 1/3 is. 1/3 is 9, and so if you have 2 of those, what's 9 plus 9? 18. Very good. Let's do another one. What if I asked you what 2, I'll go back to 9 for example. What's a third of 9? 3. So what's 2/3 of 9? 6, exactly, okay? So we're going to have to be doing some of that in our head a little bit. Now, what if I told you that 2/3 of something was 12. 2/3 of it was 12. And then I said, what's just 1/3? If 2/3 is 12. Very good. 6, okay? You wouldn't divide this by 3. This is the 2/3 part, so if I only want 1/3, that would be exactly half of that 6. Very good. Okay, so we kind of have to familiarize ourselves a little bit with how thirds work. Now, we only give you guys numbers that divide nicely into thirds. So you're talking about numbers like 3, 6, 9, 15, 21, so on and so forth. We're not going to give you something like, I don't know, 50 and say break it up into thirds, okay? It'll be nice numbers that are easily divisible by 3. So our first problem here says, point Q is the centroid, S to Q is 8, find QW and then SW. So we have 2 values we're looking for here. Now, you have to be able, and you're going to hear me say this a few times, you have to be able to decide, is S to Q the 1/3 piece, the 2/3 piece, or the entire segment? Well, I think we know it's not the entire segment, because and when I say entire segment, I'm saying the entire median. It's not the entire median, because it doesn't go clear all the way across. It stops here at Q. So then you have to decide, is S to Q the 2/3 piece or the 1/3 piece? Is it the long piece or the short piece? It's the long piece. This is clearly shorter than S to Q, right? Q to W is shorter. So that's the 2/3 piece. So I'll ask you again, if 2/3 of something is 8, what's only 1/3? 4, because 2/3 is 8, so only 1/3 would be exactly half of that 4. Oh, you guys are doing already so much better than last year. Okay, great.
It is impressive.
Yeah, you're exactly right. So then the 1/3 piece would be 4. So then how do you suppose I can find S to W, which is the entire length of the median? You just add them together, a little segment addition. 8 plus 4? 12. Now, let me go back for a minute. Q to W was the 1/3 piece. What's a third of 12? Or, yeah, third of 12. 4. And that's exactly what we had there. Very good. I think I have another one on there. I do have another one. Okay, this one says, again, Q is the centroid. V to Q is 5. Find R to Q. My little things cover that up. Find R to Q, and then find R all the way to V, which is the entire centroid. So we're going to find RQ, and we're going to find RV. Well, this 5 right here, is that the 1/3 piece or the 2/3 piece? It's the 1/3 because it's the shorter piece. Very good. All right, so I'm going to call on somebody from here. So, if 1/3 of something is 5, then I already called on you today, and you. Then, Benny, what's 2/3? If 1/3 is 5, what's 2/3? Wash my hands. If 1/3 is 5, what's 2/3? 10. You're exactly right. Very good. It's just double. Because, again, remember, guys, 2/3 is literally 1/3 times 2. That's how you get 2/3. All right, very good. So R to Q is 10. It looks like PO. 10. And then R to V, the whole thing?
15.
15. Very good. Okay, so they kind of give you different pieces. Sometimes they give you the whole segment. Sometimes they give you what I like to just call the short piece. Sometimes it's the long piece. So you just kind of have to remember thirds and such in your head. But again, we're only going to give you nice numbers to work with. What questions do you have so far? All right, let's do a little graphing problem. Now, lucky for us, this one has nothing to do with perpendicular, so we won't have to worry about any kind of slopes, so that's nice. And make sure you please label your points. So RST, and I just realized I totally forgot to do the activity we're going to do today, so maybe we'll do it tomorrow. Totally forgot. are being asked to locate the coordinates of the centroid. The centroid's where the medians meet, so we have to draw a couple medians in here. You shouldn't have to draw all 3 medians because where 2 of them meet, the third one's automatically going to meet as well. So we just need to draw in 2 medians. Medians go from a vertex to a midpoint, so it doesn't really matter where we start here. We're going to have to draw a couple of them. So I'm going to give the power to Aaliyah. Can you pick a segment up there, RS, ST, or RT? RT. Okay, we're going to find the midpoint of RT and then connect it to S. That's what we're going to do here. Find the midpoint of RT and connect it to S. Let's see if we can use slope, if that'll be a nice number. So if you can do midpoint formula or just think about slope. So from R to T, it went up 2 and over how many? 6. It went up 2 and over 6. So cut that in half. If we cut that in half, it's going to go up.
Wait.
It went up 2 and over 6. So let's cut it in half. It's going to go up 1 and over 3, right? Up 1 over 3. Okay? That's the midpoint of RT. And a median goes from the opposite vertex to that midpoint. It's a coincidence, folks, that it's vertical. It's not always vertical, so I don't want you to think in your head, oh, it's always a nice vertical or horizontal line. Nope, not necessarily. Okay, there's one median. Now I'll tell you, there is a way to find the centroid from this point, but I think it's going to confuse the majority of you, so I'm not going to go that route. I'm going to just graph another one, and we'll see where they cross. But if you're thinking in your head right now, I'm pretty sure I know where to find it. You might be right. So let's go, Angel. Can you pick a different, I already called it, I think, but RS or ST, can you pick another segment? Okay, so let's find the midpoint of R to S. R to S goes up 1, 2, 3, 4, 5, 6. Oh, that's not a nice one. That's okay. 1, 2, 3, 4, 5, 6, 7 over 3. All right. If we cut that in half, let's go up 3 1/2 and over 1 1/2, and that should be where my midpoint's at. Again, if that's confusing you, you can just do midpoint formula. Add the x's, divide by 2. Add the y's, divide by 2. But if I go up 1, 2, 3 1/2 and over 1 1/2, about right there. And it should be in a close enough spot where it'll be obvious where it crosses. Now again, I'm not going to draw a horizontal line that goes through that point. It has nothing to do with horizontal lines. I'm going to connect it to the opposite vertex. So from the blue, I'm going to connect it over here to T. And then where they cross is where my centroid is at. Which is at what point? 5, 4. Questions on that? There is going to be a couple problems on your homework like that, so I encourage you to use your notes. This had nothing to do with slope, nothing to do with perpendicular, nothing to do with just horizontal lines. Like, that's not a thing. So make sure that you do use your notes when you do those problems on your homework. Let's talk about the final segment. We'll talk about this section, and that's called an altitude. Now, you've probably heard this word before. The altitude is the perpendicular segment. And again, there is some vocabulary, so you do want to be aware of this vocabulary. The perpendicular segment from a vertex to the opposite side or to a line containing the opposite side. Now, the only place where that gets confusing is with obtuse triangles, but I think I have a fairly good, realistic visual for why you would measure it outside of the triangle. I'll do it up here. Okay, so you see this picture here, but that might be a little bit confusing to look at. Now, altitude is really a fancy word, folks, for what? Or have you heard the word altitude before in real life? When you're flying, right? When you're flying, we're at an altitude of whatever, 14,000 feet, or I don't know, that might be a totally unrealistic number. I don't know, I'm not a pilot. Or if you are somebody who goes skiing with your family or whatever, then you have altitude and mountains. So altitude is really a fancy word for height. So an altitude in a triangle is just the height of the triangle. But in a technical sense, it does not have to go top to bottom. It can go side to side as long as it starts at a vertex and then goes directly at a 90-degree angle. Now, the way I remember altitude is it has to start at a peak. It has to start at the tip of the triangle, at a peak, the tallest point. And the way I remember that it's perpendicular is when I go to the doctor and they measure my height, they always tell you to stand straight up and down, right? You can't just like lean over to the side and be like, I'm 5'1". Nope, stand straight up and down, and that's your height. So for an obtuse triangle, that gets a little bit confusing, but if you think about this, if you have a ladder leaning against something, right, and you're trying to measure the height of that ladder, and you don't measure up the diagonal here, and let's just say like you're standing over here, you have this little like obtuse triangle shape here. If you were to measure the height, you would go from the top and then measure it straight down, which happens to be a length that's outside of the triangle, but that's still where you would measure the height to. So when it says that you measure it to the opposite side or to the line containing the opposite side, that really only applies to obtuse triangles. Because if you were to continue this line on this bottom side, now it makes a nice little 90-degree angle. But you had to sort of extend that bottom side a little bit outside of the triangle. Now, right triangles are also kind of their own little thing because in a right triangle, the altitudes sometimes just go straight along the side of the triangle. Like this is the height of the triangle right here. And if you remember when you did area a while ago, then when you did base times height, that was always the two sides of the triangle that made the right angle. And then altitudes meet at a point called the orthocenter. Lucky for us, it does not have any kind of special relationship. So we don't have to memorize any theorems at all. We just have to know what the name of it is, what type of segments make it up, and then we're going to do a quick little graphing problem over it. It's not terribly important. I mean, I guess it is. So for orthocenters, they kind of follow the same pattern that the circumcenter did. So if it's an acute triangle, it's going to be inside. If it's a right triangle, it's going to be directly on the triangle. And if it's an obtuse triangle, it's going to be outside of the triangle. So it's going to look a little bit weird. So let's start again by graphing this triangle. I left myself like no space here. And then label your points. Now, this one is a little bit of a beast because we have to deal with some slope issues. If we're lucky, we'll have some horizontal vertical lines, but we are unfortunately not always that lucky. So as you're graphing that, again, it says find the coordinates of the orthocenter. The orthocenter is where altitudes meet. And an altitude has to start at a vertex. So let me just ask this question. Do we know what the vertices, each vertex of the triangle are? So what are the vertices? When I say vertices, what am I talking about in this picture right here? What are the vertices of that picture? A vertex.
Where the segments meet at a point.
Yeah, so what are, like, name them for me.
X, Y, and Z.
Thank you. X, Y, and Z. Those are the vertices. All right, so when I talk about a vertex point, I'm talking about these corner points on the triangle that existed first, the X, Y, and Z. So it has to start at a vertex and be perpendicular to the opposite side. All right, so it has nothing to do with crossing in the middle. It has nothing to do with the midpoint. This one's strictly perpendicular. Now, one of the sides up here in this picture is going to be, again, very easy to find a perpendicular line for because it's a nice straight line. Which side do you think that is? I mean, they're all straight lines, but X to Z. It's a nice horizontal line. That's what I was getting at. So let's start with X to Z. I think it'll be very easy to draw the altitude that goes to this side first because it's going to be easy to draw a line perpendicular to a horizontal line. A line perpendicular to a horizontal line is going to be a vertical line. So it needs to start at the opposite vertex and go straight down and hit that red line at a 90-degree angle. So I'm going to start at Y and go straight down, and there's my altitude. There's one altitude. Okay, it has nothing to do with crossing at a midpoint. The only time your altitude crosses at a midpoint is if it's an isosceles triangle or an equilateral triangle. That's the only time that'll happen. Now, the other two sides get a little more complicated because they're not nice horizontal vertical lines, so the slope gets to play a role here. So, Grace, pick a side, X, Y, or Y, Z. Okay, Y, Z. So I need to draw a line that starts at X and is perpendicular to YZ. So let's first start by finding the slope of YZ. Because I'm not going to know a line that's perpendicular until I figure out the slope. So I can find the opposite reciprocal. So Y to Z, first of all, has positive or negative slope, please. It's negative because it's falling. Negative slope. And then we're going to count how far up or down it went, and then how far over it went. So from Y to Z, Ashley, how far down did it go? 5. And how far over did it go? 5. Okay. And we can reduce that. What does that reduce to? -1, very good. And what's the opposite reciprocal slope of -1? 1, very good. So opposite reciprocal is going to be 1. Bear with me. So we have to still start, don't forget. I'm going to go back for a minute. Altitudes. Start at a vertex. They start there. So we're going to start at the vertex and then use the slope of +1, up 1 over 1, up 1 over 1, up 1 over 1 to draw in my line. So I'm going to start here at X and I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And then our two lines, and now it crosses at a right angle, that green line. If you look at the two green lines, I'm trying to color code here, the two green lines should look like they cross at a right angle. And then where those two altitudes cross is going to be your orthocenter.
Now I'm looking at your slope of YZ. And we have -5 over 5.
Mm-hmm.
Is that correct?
Mm-hmm. And where did those two lines cross? -2, 2. And that's your answer. So, in conclusion here, this chart's on your notes. This breaks down, and I'm going to give you guys a different graphic organizer tomorrow. This chart breaks down what the segment we've gone over is, what it looks like. I can tell you guys on the test, you're going to have to match each segment to each picture, where they meet, what that name is, and any important theorems that they have. The altitude doesn't have one, and then kind of what that picture looks like. Now, I think for the next 10 minutes here, I think what I would like is for you to at least on your homework do the front page for sure. We're going to have tomorrow to review this. We have 2 more days of review before your quiz. So I think maybe what I'd like is just, how about the homework right now is just the front page. And then tomorrow we can maybe do a couple graphing ones together again, because I know the graphing is the hardest part. I'm very well aware for most of you. I would say all of you, for most of you. If you want to work, you know it. So if you want to work ahead and get the graphing done, by all means, go for it. But let's just make sure that we for sure have the front side of the worksheet done. Okay. And then tomorrow because I didn't get to today, one of my favorite things is centroids. Forgot to do it, so I'll do it tomorrow.